various floors of the building. The stair consists of series of steps called flight with landings at appropriate intervals. Stairways are made up of individual steps. Each step consists of a tread and a riser. The tread is the flat part that you step on, and the riser is the vertical up or down part between each tread in the stairways. Okay, now there are many types of staircase. Among the types, dogleg staircase is the most economical and common format of staircase. These stairs are arranged with two adjacent flights running parallel with a mid landing. Where space is less, dogleg staircase is generally provided, resulting in economical utilization of available space. In this type of staircase, landing is provided corresponding to the level at which the direction of the flight changes. So, in this lecture, we are going to solve a problem. Actually, we are going to design a dogleg staircase of an office building. So, let's read out the problem. Design a dogleg staircase for an office building in a room measuring 3 meter by 6 meter. This is clear dimension. Floor to floor height is 3.5 meter. The building is a public building liable to overcrowding. Stairs are supported on brick walls of 230 mm thick at the rate of the end of landings. Use M20 concrete and Fe 415 steel. So stair is a very important part of building. This may be a office building, maybe a school building, maybe residential building. So loads and geometrical design for comfort is depending upon the type of building where staircase we have to design, we have to place. Load conditions are different, live loads are different for type depending upon the type of building, and we can select the riser and tread depend upon the type of building and depend upon the crowding, right? So first of all, before RCC design, we have to design the geometrical design of staircase. So let's have a look to the plan of a staircase. You can say this is the plan after geometrical design. We will definitely go through the design, but this is I am showing just because of a rough idea. Here is a plan, 230 mm both side, the wall support. After that there are two landings, and in middle there are two flights. So in a floor to floor distance, we have to provide two flights for dogleg staircase. Okay, so let's complete the geometrical design. So proportioning of various dimensions of staircase. Width of staircase is given, that is 3 meter. Considering two flights of dogleg staircase, for a floor we have to definitely consider two flights for dogleg staircase, right? Let's space between two flights 0.3 meter or 300 mm. We can assume that data is not given in question, but we can assume this as 300 mm or slightly less than that. But in this problem, I am assuming is the space between two flights is 300 mm. Width of each flight total is 3 minus 0.3 meter, that is the space, divided by 2 for each flight, that is equals to 1.35 meter. that this is the width of each flight. Now floor to floor height is given, that is 3.5 meter. So height of each flight is equals to 3.5 meter by 2, that is equals to 1.75 meter. Now assuming the height of riser as 150 mm, which is comfortable for office building which is overcrowding. Okay, so now number of stairs will be height of the flight divided by the riser height, that is 1.75 meter or 1750 mm by 150 mm, that is equals to 11.66, or we may write 12. So we have to provide 12 number of risers. So from the geometry of staircase, we know trade required will be definitely less than, just one less than the riser. So number of tread required is equals to 12 minus 1, that is 11, because the last tread will be the landing. Okay, so let width of each tread is 300 mm. Therefore total going is 300 multiplied by 11, that is equals to 300 into 11, that is equals to 3300 mm or 3.3 meter. Look, now total length available as per question 6 meter, right? Now width of each landing is definitely 6, that is overall length, minus 3.3 the going, so available space, that is the available space, by 2 equally divided in two side of the running, that is equals to 1.35 meter or 1350 mm. So let's check out the figure as per the geometric design. This is the plan of this dogleg staircase. All dimensions are written as per the calculation. So total is 6 meter and the width is, length is 6 meter and the width is 3 meter. Okay, so 6000 mm and 3000 mm. Okay. Now run is 3300 mm and total number of tread per flight is 11. So this is marked here 1 2 3 4 5 6 7 8 9 10 11. The 12 number is the landing, mid landing. After that 13 14 15 16 17 18 19 20 21 22 23. After that the floor. Okay, so two landings, the each landing is 1350 mm, which is calculated, you can see here, and width of each landing is also 1350 mm and spacing in between is 300 mm. So this is the geometrical design. After that we have to design the reinforcement for this staircase. So in case of design, we have to design only one flight because another flight is just similar that. So in case of staircase design, dogleg staircase design, we have to design only one flight, and one flight is a continuous waste slab. Among the waste slab, the loading system is varying because there are two landing with same load. After that there are few steps. So this middle portion of the waste slab definitely carry a extra load. So in analysis we will see that uniformly varying load will come in this waste slab. So, before starting that, we have to know what is waste slab. Look, waste slab is nothing but the normal slab which is in some inclination angle between two support, mainly used in RCC staircase. Waste slab is raised on the beam to beam, and main stair reinforcement still goes up to the mid depth of the resting beam. Waste slab thickness will depend on the length of the stair run. Okay. So let's start the design. Now effective span of flight is equals to center distance of walls. So 6 meter is the clear span plus one bearing, half bearing plus half bearing both side, one bearing, that is 0.23 meter. So 6.23 meter is effective span or 6230 mm. Now thickness of waste slab is, as per thumb rule, L by 20 of span for simply supported slab, that is equals to 6.23 by 20 into 1000, that is equals to 311.5 mm. Now let us take the effective depth as 300 mm. We assume that effective depth is 300 mm. Now we have to calculate overall depth. We may provide a clear cover of 25 mm. So 300 plus 25, that is equals to 325 mm, that is the overall depth. Now we have to analyze the loads, which is depends upon overall depth, riser size, tread size, and definitely gamma c, that is unit weight of RCC. So first, weight of waste slab per meter width of flight, okay, that is equals to capital G root over 1 plus capital R square by capital T square root close multiply gamma c. Now capital G is overall depth, R is size of riser, T is size of tread, and gamma c is unit weight of RCC. So D is 0.325 root over 1 plus riser is 150, so 150 square, and by tread is 300, so 300 square into 25, that is equals to 9.1 kilonewton per meter. Now weight of steps. So in this part we have to calculate weight of the steps, that is equals to half into gamma c into R into T by T. Gamma c is unit weight of RCC, R is riser, and T is tread. So this is equals to 25 R by 2, that is equals to 25 into half into 0.15, 0.15 is riser, that is equals to 1.875 kilonewton per meter. So total dead load here is 9.1 plus 1.875, that is equals to 10.975 kilonewton per meter, and live load is given, that is 5 kilonewton per meter square. Okay, so total load, that means dead load plus live load, is equals to 10.975 plus